The first question is why C? And I guess you don't know what this name is, TIUB. I guess nobody has heard about it. It's a super weird ranking about different language. So it's not a ranking about how many lines have been written. It's not a ranking really how much better a code is compared to another. It's mainly tracking online how much support you're going to get. So how much popular a code is online by basically how many questions are on Stack Overflow, how many tutorials are on the web and stuff like that. So I don't know the exact formula, but it's a weird way, but it's typically a way to see if you want to start a language, how much you need basically you're on your own or how much support you have. And basically C, you don't see that much all the time. I mean, for myself, you don't see it. C is basically number 1 or number 2 since something like 20 years. So for the moment, it's actually currently number 2. Number 1 is actually. So number 1 is currently Python. I mean, the plot is not up to date. It's increased a bit, but I checked yesterday. Number 1 for the one is Python. So number 2 is C. I think number 3 for the one is C++. Java pass number 4, and the 5th one is C#. So you can see that out of those first 5 languages, actually 4 of them are C related. I count Python as C related because Python is mainly an interface to C. And the back end everything is running at C now. So the only one which is not related to C is actually Java. So what it means by that, it's basically a super well established code, super basic code actually. So you can see there is extension like C++ and C# that we are not going to cover today. And one of the main reasons why I'm giving these lectures is not about making you expert in C or telling you, oh, you need to use C and not C++ and stuff like that. My main point is that you have all the basics for what I care about is Cuda. So basically how to use GPU. So that's my main goal for today. Just for information, Fortran that you're going to see this afternoon, some people say it's dead. It's still top 16 here. We still have quite a lot of support on the web for Fortran, even if a lot of people say it's dead. It's used quite a lot, of course, for science, but I would say it's still 16 where people say, oh, you should use Julia, because I know, for example, Damien likes Julia a lot. Julia is 25 or 30, for example. Rust, which is also supposed to be super popular, is 20, so Fortran is still well established. But C, of course, is one of the most important codes. So what we are going to do today is basically a lot of basics. So that will also be, I mean, I have 2 purposes for these lectures. One, of course, will make you learn what C is, but also what programming is. So I will recover a bit all the basics of what is a variable, what is a functions, how do you pass variables, arguments, and stuff like that. So if you have no idea about how programming, I will recover everything. If you know already quite a lot, any language of programmation, it might be slightly boring in a way. I personally not a C, C++ expert. I'm more on the Python side, to be honest. So really, I'm not going to track the most up-to-date feature of C++ and stuff like that. It's really explaining the basics, basically. Okay? So what is the main point of C? So C is an extremely old language. And if you look at Wikipedia, what is going to say that by design, C provides constructs that map efficiently to typical machine instructions. So that's what we call a relatively low-level language. So that's a language that is actually super easy for compiler to take your instructions and convert them to machine instructions. So what is the advantages of that? Since the job of the compiler is easy, that it really means that the code will be super optimized and quite efficient. Compared to, for example, C++, since you have so many levels of abstractions, so many possibilities to do weird stuff, that your code cannot be as much optimized. That's the advantages, I would say, of Fortran and C. Those languages are basic. You cannot do super crazy stuff, and they are quite optimized. It doesn't mean that your code is going to be faster in C than in C++. Quite often in C and in C or Fortran, you have to reinvent the wheel, I would say. Like in C++, you use a class vector, and you have way to sort the argument and stuff like that. In C, quite often you have to either find a library somewhere on the web or invent yourself the stuff. And typically, when you invent something yourself, you are less smart than data experts in those kind of stuff. And then your code is going to be slow, not because the language is slow, but just the implementation that you've used is slow. And for example, Python, when I translate a code from Python from Fortran to Python, Python is even worse than C++. Python is super, super slow, but my code was 10 times faster at the end of the day, just because instead of sorting everything myself, I let Python do it. And Python on the back end was using C, obviously, so it was fast, but that's the kind of stuff that should not happen in principle. So that's also the point. Don't reinvent the wheel. And that's super easy to do in C and Fortran, because you don't want to search if someone already done it, and then you have to link to code, which is boring. Typically, you say, oh, I'm doing myself, it will be fast. It will be fast to implement, maybe, but not that fast in execution. So let's start our first C code. So as usual, we always start by an hello world example. So let's go. Okay, can you all read this? I guess it's big enough, right? So the first thing, of course, in any language you need to know is comment. So in C, comment is double slash, or you can also have multiple line comment with this slash star, and then you need to finish by a star slash. That's for multi-line. This is a lot of include, that's pre-processing, so include code. So in this case, stdio, it's to basically be able to print stuff. And of course, for hello world, we need to print. And this is your main code. So that's the main function that is going to be executed when you run the code. By convention, here has the name main, and that's returned an integer. So like, I think you have seen, maybe it was not discussed, I don't remember if it was discussed at the Bash lecture or not. Every code in Linux returns either 0 or number. 0 means that the code returns correctly, 1 or higher means there is an error. So that's why your main code is supposed to return a number, and by default, I return 0, saying, okay, everything was correct. If there was an issue, you return another number, and then the code knows that in principle it has to crash or basically at least claim that there was an error so that we can handle it later. To print, that's the C way to print F. You put your string, and you don't have to forget that that's typically a thing you forget, and it's not mandatory, the /n to say that you need to return at the next line. And that's it. Did I miss something? Yes, the curly bracket, I guess. So that's where a function start and stop. That's what we call a block. So compared to a Python, where, for example, you have only indentations, or some code that have keyword, here we start everything by the curly bracket and ends it by the curly bracket. Empty line doesn't have any meaning. Space doesn't have any meaning. So you can add and remove space whatever you want. And that's basically it. I'm checking that I'm not forgetting something important. Of course, I did. End of the line is a semicolon. So that's always super important. And that's the stuff that we'll forget most of the time is to put a semicolon after one command, and then the code will not compile. Okay. So next question is how to transform that code to an executable. And the easiest way, at least for simple program, is just to use make, actually. So if you do make, the name of the file, but where you remove the extensions, so make hello world, then you press enter. And of course, in this case, it say, oh, it's already compiled, I don't need to do it. So let me remove it. And it will give you the C line, I mean, the compiler line that you need to use, CC, the name of the file, -O for creating the output. With advantages first to having that line completely automatically, so you don't need to remember it. But then, of course, you have the template you can update. So, for example, you have seen at the last lectures, I mean, for this example, it doesn't make any difference. If you want to have it compiling better, which is more optimized, you can, for example, add -03, and then it compiles the code. So in this case, of course, there's no mathematical operation. There's, I guess, no way that there's a difference between the two codes. But just to remind you what you've seen on Tuesday. Okay, and then after that, you can execute an hello. So as usual, you always have a C compiler on all cluster, but if you do CC minus versions, you'll see it's super old. So it's a GCC4. So as usual, it's better to do something more modern. And doing something like modulo GCC or modulo FOSS. And now if I'm doing the same, you will see that I have GCC 11 now. Yes, GCC 11, which is of course much more modern. So some of my example, so in that table, will not compile actually with that version of GCC. It's just too old. Oh, yeah, that's the simplest command, compiling directly by the calling CC. If you have any problem, if you want, I mean, if you don't succeed to compile on the cluster, which should not be happening on stuff like that, all my example on the slides, they've always a link normally to one of those websites, which are basically a way to you arrive with your code and you can compile directly online and run online. If everyone is running online, is doing editing code and doing some mistakes, at some point that website typically crash because you basically, someone make a memory leak and basically the virtual machine has to reboot. So if everyone is doing that during the lectures, typically it doesn't hold the full lectures. So I'm not going to use it myself, but that's also solutions for today. But in principle, you all have access to the cluster. You can run on the front end, that's not the issue. If you just do this kind of stuff, no problem. Okay, so I would propose you that everyone is trying to compile at least the hello world example. And when you succeed, you put you answer these questions by yes, so that I know that everyone can at least do this super basic stuff and say hello. And I guess I can see the result real time. Yes. Don't let you do what? Because you try to compile the one that .c file, then you need to move the .c. So you're on the no, you're on you need to go to this. The content administration inside your own. Because then, I mean, everyone is in that that directory. So we don't need the right to we don't need right access to that directory. You need to copy CT minus R. Go to your own stuff. Go back to your own. only 4 so far. Would it help? We are 3 here, so we can provide as much as needed. 5. Better. Need help? No? C'est des menus différents, mais c'est des... Donc si j'ai pris FOSS, et si je fais module list, il me dit en fait qu'il load tout ça, qui inclut GCC, mais aussi plein d'autres dépendances en fait, qui contient les trucs typiquement intéressants, style Blast, PMI, c'est tout ce qui est... donc c'est ça que c'est à peu près le défaut, j'ai envie de dire, FOSS. Ça comprend OpenMPI, ça comprend vraiment ce que j'ai considéré les librairies de base. Donc dans ce cas-ci, tu pourrais prendre GCC ou GCC Core, qui est encore un peu plus petit. La différence, c'est ça. Voilà. C'est juste ça, c'est un peu mon standard, j'ai envie de dire. Enfin, c'est le truc par défaut qui a... Dès que tu vas faire quelque chose d'un peu avancé, de toute façon, il va se baser sur ces paquets-là. Et en fait, on parle de release, ça correspond quasiment à des versions de POS. Parce que tous les programmes qui seront dans la release 2021B vont typiquement être compilés soit avec Intel 2021B, soit POS 2021B. À peu près tous les packages vont avoir cette dépendance à part de ça. Toujours 5. C'est 6 qui n'arrive pas visiblement. Qui n'est pas encore arrivé à lancer le level. Okay, je vais venir voir. Damien, tu sais voir là aussi, comme ça on avance trop vite. Or you can just use the terminal, no?
Which cluster?
Whatever. You can take le maître tuyau qui exploite. Let me do the first step. So that's... with a slash, yeah. How do you get this one?
I don't know why this is so.
No, that's okay. No, you should save the file. This here. So now you have to compile it, and then you can execute it. You were good, or you want to help? Yes. Okay. Do it. Yeah. Anyone else needs help? No. Okay, so let's, for the one we have not yet finished, they can still finish the first exercise. For the one I will slightly move forward just by open questions, actually. So basically, only with this printf, you can do already cool stuff. So a lot of my example will be quite basic because I was inspired by my kids, which basically learning multiplication table. So you will learn today how to do multiplication table. Sorry for that. I hope you know all those answers by heart, obviously. But that's my first code. After hello world, I'm doing something a bit more interesting. So this is my super code. And my questions to you, for the person who have already finished the first exercise, is basically what's wrong with this code and what can we do to improve it? So that's my question. So I will put the code back. This is this one. And what do you suggest, what you can improve, or you say it's perfect and then we are good? But what do you think it's not perfect in this code? What can we do better? There are no bad answers, I guess, here. Yeah, oh, you can propose it. So let's check your answer. So the first suggestion is, okay, that's cool. I never think about that one. When you place all those printants inside a single printf instead of 10 different ones. Yes, I would not say that will not change too much. Actually, I don't know if that's working. Well, let's try just for fun. So for sure, if you do like this, it will work. Then it's a single line in a way, but then it will not be that readable at least. So that will, I mean, this will compile for sure, but that will not be that readable. What would be more readable is something like this. But that I'm not sure it's going to compile. So let's try. Yeah, it doesn't compile. So it's possible to do it on one line, but that readability will decrease quite a lot. And I don't, maybe there is one way to make printf on multiple line nicely on C, but I don't know it. Maybe it's possible. I don't know if you know a way to have multiple line in C for printout. No. So yeah, it's possible, I mean, on a single line, but then readability decrease. And as Damien said last time, the first things to do is to be readable. So next suggestion is, can we make a loop? Yes, obviously. Loop, loop, and loop. Actually, that was not my first suggestions. So let's make the loop later. My first, personally, the first things I don't like here is in a way that I'm repeating myself quite a lot. And it's not very flexible in a way. So let's say I want now to change this by putting to my kids the table of multiplications of 4. I need to edit 11 lines. I need to edit 11 lines and 11 times basically the number 4, and of course, all the answers. So it's not very, I would say, practical in a sense. That's what I call a movie code. It's a movie, right? When a movie, you basically do all the pre-processing, all the computing in advance, and then you basically tell the movie, print this on the screen, print this on the screen, print this on the screen. And that's exactly, in a way, what I do. So that's nice in a way for presentations, because you do everything in advance, and that's super nice. Of course, in a movie, you don't want to wait 1 hour for that the special effects are computing on your laptop. But obviously, typically what we want to do is something different. So my first optimizations on this code is actually not the for loop. It's actually the first things I want to do is introduce a variable, such that basically now I'm letting the computer doing the computations for me. That's the main step. So in C, and that's different from Python, for example, the language is strongly typed. So you have to say that you define a variable, that variables will be an integer. So you have to be forced to say that variables now cannot be a float, cannot be a Boolean, cannot be a string. It will always be and need to be exactly an integer. The value can change, so that's the initial value here. It can change over the time of the code, but it will always be of type int. It will always be an integer. Why is that more interesting than Python? Is that we know basically the size of memory of an integer. So we know how many bits inside your memory you need to assign to an integer. In Python, since we don't know it starts with an integer, but 5 minutes later it can be something else, we need to assign in Python a lot of memory, even for true-false statements. So even a true-false take the size basically of a double, because they don't know that later in the code, that true-false can become a double, basically. So the fact that we know in advance that an integer allows more easily, at least, to have optimized code in terms of memory. Is there anything else that I need to say? Yeah, the second thing I want to stress is how to print now variables. You put this %d, and then the variables that you want to print at that positions. So this one is going to be printed here, this one is going to print here. Not the most intuitive way to print, but relatively practical at the end of the day. And we'll see later that each type of variables will have its own letter. So D is for all the integer, and we see later that we have other letters for other type of variables. Okay? So now what you wanted, the loop. There is the first type of loop that I'm presenting here is the while loop. So that's very simple. You put while the conditions, and then you print this, and then of course you need to upgrade J in this case. So in this case, I have a variable that updates every time, but it's exactly the same. Of course, this is much more readable in a way. I mean, at least much more compact. Readable, I don't know, but at least it's much more flexible and very easy to write, obviously. Yes. Any questions on this? Pretty easy normally. All the space, you can remove them or not. You choose your own conventions. Typically, this I found a bit ugly to not have any space, and I don't like typically to have 2 space here. So I would say typically I put the space after the equal, but not before. But that's really a conventions basically, and then the best is to follow what your colleagues are doing typically when you edit their code. Okay. One thing I like a lot in C, and for example, we don't have that in Python, for example, and I liked it a lot, is this for loop. We also have for loop in Python, but not as powerful as this one, where you basically do everything inside those parentheses. You define a variable, j equals 0, so initialize it, tell up to when the for loop is going through, so up to g smaller than 10, and what you do at the end, you update j by adding 1 to it. So plus plus is the same as equal plus 1. So for me, it's super practical because in one line, you have all the conditions. So it's exactly the same as the while loop before. The only difference, and that's why I don't like that much this, is then you put these conditions at the end. So you have the possibility to forget about it or stuff like that. While the for loop, especially the for loop in C, is super practical syntax to me. Okay. One comment, and we'll understand later why, but in C, and it's like in Python actually, so all the C code, we typically start to count at 0. So for loop, typically we're going to put the first integer to 0 and not to 1. And we'll see later why we do that. It might be counterintuitive, I would say, for beginner, that it makes more sense to start at 1. It's more practical to put it 0 in practice. At this stage, you do whatever you want, obviously. But you will see later that 0 is much more natural. Okay, so a small quiz. So if this code, and basically I'm going to ask you what that code is going to do. And I have 4 possibilities that you can read yourself on your screen, or I can read it there as well. Either the code will not compile, the code will print after the loop I equal 5 and j equal 0, or I equal 5, j equal 10, or I equal 5, j equal 11. That's the 4 possibility. And this is the code. So normally, if you click, because you should see also this on your screen, and if you click on it, you can see also the code in big on your screen, basically. We need 5 answers so far. If you don't know, just make a guess so that we can have, let's say, a bit more votes, so we can look forward at the answer. So let's take a look. So yes, or someone wants to vote right now? No. Let's take a look. So 3%, just when I say that someone is voting, of course. So 4% thinks it's moving live, that the code will not compile. When it produces I equal 5, j equals 0, I equal 5, j equal 10, and I equal 5, j equal 11. So let's do it. Which one it is? That's the correct. Let's look at the code. Yes, and just comment this. So it's not compiling, and that's the interesting part actually of this example, is that with this line it's not compiling. And now if I'm commenting it, what's going on? That's the work. What did I do a mistake?
Are you sure you put combine the
Ah, maybe it's not. Yeah, you're right. You're right. Thanks. So yeah, but then my example showing this it's not conclusive. But thanks a lot. Yeah, and now it tells you even why. Actually, it's even better. So if I uncomment this line, it says that no, I cannot compile this code because J is actually not defined. So this can be a bit surprising. And actually, why J is not defined? Because J is actually defined in the for loop. But outside the for loop, actually, it's considered as undefined. So every variables, and that's in any language, have what we call a scope. So basically, a part of the code where the variable is defined, and the rest of the code where the variable is not defined. That's super practical because that means you can define the same variables in different scope, for example, they will not interfere. And when we have 10 lines, that's not, of course, a problem. When we have 1,000 lines for code, if we have to have each variable with a different name, you are stuck. So in this case, the J is actually defined between those two curly brackets. And outside of the code is actually no J at all. So in that case, that's why it's crashing, because you just say, at this level, I have no clue what J is. If you want to keep the value of J for whatever reason, what you can do is define it outside. So you can define it here, and then here remove the int, and here it's initialized J to 1, which is fine because it's defined between those two curly brackets where the J is defined now, and then it's going to do here, and here it's going to print one value. That should be, I guess, 11. And yes, it's printing I equal 5, J equal 11. So I would say those four were not completely wrong. It's just that they missed the scope. And that, I mean, it was a tricky example, obviously, to make you realize that scope are, of course, there, and that's important. That's the game of the exercise, obviously. Okay, so to recap, there's three types of loop. The for loop, which is typically the one you're going to use the most, the while loop, and there is a third type of while loop. It's do, then your code while in the conditions. The main difference is that you are sure that you go to the code at least once, because you check the conditions at the end and not at the beginning. That's the difference between those two. And then, like everywhere, you have two special keywords. The continue, just to say bypass everything else inside that block and restart basically from the beginning. The loop, I mean the next iterations basically. And break is to stop completely the loop and go basically to the rest of the code. In some language, you also have some go-to, but basically the common rules is never use go-to in the language, because that's make code impossible to read. Okay, a bit more on variables. So I already described the syntax for instead. Okay, what's going on? Okay. Sorry for that. I'm not sure why you want me to send an email now. Cinda? Yes?
I tried to compile the example, but
which example? This one? No.
The one where J is not
yes.
the one where J is declared inside the for this one.
So when you put int here,
yes. Oh, okay.
You see, I put the in outside to make it working.
I see the mistake.
Okay.
I forgot to set.
Ah, that's, yeah. Very, very common, very common. Okay. So there are other type of variables. So float, those are single precisions floating number. Double are double precisions floating number. So it's just the size of memory which is different, and therefore the precision of the computations. At least in my field, floats are quite often not precise enough for computations. Because the issue is you have two numbers that are very close to each other. When you make a subtractions, then you have quickly very large uncertainty. And that's why typically I never use floats. So we try to use more and more floats because it's faster, especially on GPU. But it's super difficult to make your codes compatible with floats. So the default typically is double. And then you have character, which is char, and it's for one letter. So in C, you don't really have a type for string. You will have that in C++. But we'll see later how string are handled. We need a bit more to handle string. And true-false statements are actually supported now, but you need to add an include in order to have true-false statement. As I said, to print, you need different type of letter. So D was for integer. F is for float. Doesn't matter if it's single or double precisions. And character, well, is C.
What is the distinction?
It's with a number of digits. So float should have 10 to minus 7 accuracy, while double 10 to minus 15 accuracy. And normally there is also quadruple precisions. I don't know the syntax in C. And that is super high precisions. Yeah, that level starts with even multiple definitions of, because you can play with the number of digit after the comma, but also to the exponent. And you have the two actually. And now in machine learning, they also play with half precisions, which are super inaccurate in a way, but for machine learning, they have so many parameters they don't care about accuracy in a way. They just want to find a minimum. So basically it's not critical, the precisions in the parameter. Yeah, obviously you cannot define the same name twice in the same block. But if you have different block, and we'll see later, of course you can do it. Because each has a scope as we've seen before. Okay. So the next improvement, you didn't put in the list, but for me, what would be interesting. So if you go back to this multiplications example, or still there actually, is to put a function for it. So that basically now in my main code, I can just say print the table 4, print the table 5, and just how much, if I put two parameter, up to which is the maximum value I print for the, for this line. How many times I print this line, basically. So for doing the functions, the first thing you need to do is to define the functions. It needs to be technically defined before the first time it's called. So it's important that this block is actually before the first times this line appear. There is a way to avoid that. I will show you later, or maybe I can show it in the example in 2 minutes. But then it's, you will see. But basically, it needs to be defined before it's called the first time. That's the rule. Then you put the parameter that you want. Here I want 2 and 3. One is an integer, the second one is an integer. I put them name, and that's the name that will be given here. And then I put my for loop as before. Okay. Now in my main code, I just have to call that. So no, what's going on? Okay. So this is exactly the same code normally. Well, not exactly, but okay. So just to show you what we can do, maybe Damien will need your help for Vim. We'll see. So if I want to kill multiple line, it's D, and then I go the arrow, right? Yeah. Only 2 lines. I'm trying to learn Vim, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 9. I guess I did too much. And now paste. Okay. So you see here what I do, I put the definitions after the main functions. And I said this will not work. And the way to make it work is to do this. Void print. So it's just defining above what is the signature of the functions. So it's a functions printable that return nothing. That's the meaning of void, and that's take to integer. So that's basically enough for the code to know what to do with this line. And that the definitions of the line is actually later, that's not an issue. So quite often for C or C and C++ projects, you will see actually two files, one called .h and one called .c++ or .c. Typically the .h are all those lines like this, where you put all the definitions, and then the .c or C++ that include all the actual code. And that's allow you to basically include only the .h, so it includes all the definitions. You can include this line like this. And then you can call all those functions without having to redefine the full code every time. So that's the reason why typically in C you have two files. I'm not going to use any two files here in these lectures, but that at least you know why it's here. So now I can try to compile this just to show that it works. Yoo-hoo. And then I can call it. Okay. So the main goal, of course, of functions is to not repeat yourself multiple times. That's kind of clear. Only the parameters that are passed here are passed to the functions. And they are passed what we call by value. So we take only the value of the object. And that's actually a different, I mean, it's completely separate from this code. So a key point is arguments are not modified. And for that, I have questions for you. So here I have a function, which is printable again. But here I'm doing something a bit funny. But first I'm having, oh no, I think that here that's fine. Table of equal table of plus one. So I'm changing one of the parameters that I take an entry. I'm allowed to do that. And the other stuff, which is a bit more funny, but I'm also allowed to do that, I pass twice actually the same variable here. So table of and table of. So the question is again, what's going to happen? In this code, the code will compile. I don't think, yeah, actually, I didn't allow you to choose the code will not compile, so that's not telling you the answer. So in this case, the code will compile. The question is what's going to happen. When you the person to always increment that you are starting with, and then to save the test. Yeah, I'm cheating here since I'm trying to learn AI. But for me, that's why it seems like Emacs because I'm used to that command. But in practice, that's been open. It's my for myself. So let's take a look. What do you think? So 2% thinks it's going to enter an infinite loop. 5 that will be the code will print 5 lines, and table of will be printed as 5, and then 1 for the 2 others. So actually, I already run the code in front of you because that's exactly this code. So we'll see that indeed there is 5 lines. I think that's this one, right? Let me double check. No, actually, no, it's not this one. It's Wooclap. No, not this one. Which one is then? Okay, let's do it then. Let's take this. And then do this one. So same error as usual, the semicolon. Where is it? Yeah. So indeed, 5 lines printed. I didn't do the print statement, but I add the print statement in the main code. You put the slash n, but you see it stays 5. So a function is not going to change the variables. That's what I said before. And what is important in a way as well is that even if here I pass the same variables to both arguments, at this stage, there are really 2 different variables actually. So they're completely separated. What is happening under the hook is actually here it creates a new variables. Here it creates a new variables. And since you pass j for both, it initializes these variables with the value of j and this variable with the value of j. And now in memory, technically you have 3 integers, one of j, which is staying here, one for table of will be destroyed at the end of these functions, and one max entry that will be killed as well at the end of these functions. And that's why when you keep these functions, j will never be touched because it's staying here. It's not part of this. and you can update complete independently table of or max entry because there are two completely separate variables in memory. Okay. Yeah. So, of course, in practice, sometimes you want to change a value, right? You want to pass a code, and you can say update the number of participants, or you have basically a database that you want to update or something like that. So sometimes it's super useful to be able that the functions is changing a variables of the main code. So that's why address and pointer are useful. So I always found, at least myself for years, that pointer and address were super confusing. So let me take the time to really assess what is a pointer and what is an address. So looking at the address first, so what we have a variables. In this case, we have a variable I, which has an initial value of 5. What it means that under the hook, I have my RAM, and inside my RAM, I have, let's say, 8 bits in order to, and that contains the value of 5. So at runtime, basically what my computer is doing me is assigning me a place inside the memory, and then to the variable I, it's saying that corresponds to that place in memory. That's what we call the address. That's the address of the variables. So you can know what address is assigned to your variables, and that's passed by this symbol, the ampersand, and then the name of the variables. That will give you the address inside of memory. So if I'm trying to print that, I think I have a code for that. So that's exactly the same code. So the main, and then say E is stored in RAM at the address. So you see it has a dedicated symbol again, it's P, and then you put the address here. I prefer not to answer now, to try to avoid. The idea is pointer, but I don't want to, I want to keep address, so that's why P, but okay. I want to make it clear what is a pointer and address, and at this stage it's a bit confusing if I say that. So that's why I didn't want to say P is for pointer. So if I'm compiling this, which I already compiled, I guess. Yes. So you see that it's table of 5, nothing, and here it tells me a number, which is this one, which I cannot do that much with that, but that's the place inside my RAM where the variable I is stored. Okay. So normally, in principle, it's random, but you'll see that if I run multiple times here, I always have the same stuff. But in principle, if someone else is running and stuff like that, this number can change between 2 executions. There's no reason that it's always the same. Of course, here, I would need someone to stress to use more RAM on the method tree, and then that number will change. Go back here. So that's how you get the address of a variable. So now at this level, if someone would told me, okay, that's great, I know now where it's on the RAM, basically I didn't gain anything. Because at this level, I would say, for me, first it changed each time I run my program, and I can do too much with that information. So why it's a bit useful? Because you have this operation, which is you can ask to change a value at a given address. So if you have the address of a variable, instead of saying change the name, you typically have the name of the variable change where it is. Here you change according to the address. So you have this huge number, then you say, you take the address, star in front of it, and put equal 5. That means I'm going to change the bits at that place in RAM and put the value 5 instead. So it's exactly the same in a way like this, but it's another way to change the variables. Okay. I guess I will skip. Well, I will show, but I will not let you answer this. So that's one way to change variables as well. You have the variables, you take the address, then you put the percent in front, the star in front, and that's changing the value as well. But if you do this works, but will not help you for what I asked you, introduce you the problem for, but it's changing this value here. So this is exactly the same as just putting table of equal table of +1. What you are going to change is the variables table of, which, as I said before, is completely independent of this one. Which are the same name in this case, okay? So this will not help your problem at all, because there are two different variables completely. What is? I missed a slide, I guess, no? Yeah. Yes, that's the slide I want. So now what I want to pass to a function is actually the address directly. So if I pass the address, then I cannot change that address, but I can change the value inside that address. So what I do is to put the address inside the variable. So as everything is typed in C, what I need to do is to say, I'm defining a new name, PI, so P is for pointer here, which is going to store the address of I. And then since everything needs to be typed, the type is int and then a star. So what is confusing in C and C++ about pointer is that you will have star bits everywhere, but they will not have all the same significations. You have, of course, the multiplications. The star associated to a type, so saying that's a pointer of an integer. And you have also the star to make the assignment, as you've seen on the previous slide, but which is here as well. Yes, now you can. Yeah, the reason why each pointer has a different type is because the number of bits assigned in memory. So we need to know basically that's a pointer of an integer that can only change 4 bits, but it's a pointer of a character that can change, I don't know how many bits and so on. And this is the variable that we call a pointer. So a pointer is a variable that stores an address, and an address is a place on the RAM. Okay, any questions? So now you can, I have these questions for you. So now instead of passing integer directly, what I do is say int star px, int star py. So as the argument of the functions, I'm now not passing a variable, but a pointer to variables. Then I'm doing this. And the questions are to these comments, which is make it relatively clear what's happening. And then the question is the variable at the address px and the variables at the address py are changed after this code or not? Okay, let's look. Yes, correct. I mean, half. So only the value stored at the address is changed, not the address itself. That's the correct answer, actually. So the argument itself of the functions, oops, what did I do? Just okay. The argument itself, which are the pointer, will never be changed. So if you try to change the pointer, that will not work. At least they will not be changed inside the main code. But the value which correspond to those pointer will change, thanks to those lines, actually. So that's exactly, I mean, a simple rule. Basically, if you don't want to change a variable, you pass it by value, and you pass its value. So int px will only pass and then you will not be able to change. If you want to change something, you pass a pointer. Okay. And that's super important to realize, of course, that not only for C, but also for Python, because it's basically the same idea, even if Python is a bit more complex. Okay. This I will skip. Yes. That I already said, I guess. Yes. I don't think I have the time. Anyway, there's nothing interesting. So if statement, I guess you all know what the if statement is. So no point to go in details. The only things which is boring, I would say, in C is the syntax for all the logical operators. So that you need to know. Double ampersand means A, double bar means or, and the point mark, that's quite common, at least not. But those two are not that readable, I would say. One thing I didn't put it. You put it here. There is this syntax, which is not the most readable, but which is super useful, saying if this condition is true, then you take the first argument, so the one after the point mark, then you take 2. If that condition is false, then you go to 4. That's a one-liner for if-else conditions, which is super useful. No, not the most readable. I prefer Python, where there's also one-liner, but with if and else, which is much more clear. But that's super useful, and you will see that in a lot of code. That's important to know. Okay. The last big thing, and that explaining before why in C we always count at 0, is array. So for the moment, I always speak about variables, which is one number, one float, one string, not yet string, one character. So here what we're going to do is a series of numbers. That's what we call an array. So it's not one double, but here it's a suite of doubles. In this case, like 1, 2, 3, 4, 5. And then you can access them one by one by this syntax, so square bracket, and then the index. So the index, that's why in C we always start at 0, because the index starts at 0. So 0 means the first element, 1 means the second element, and so on. So it's not the same as Fortran that you will see this afternoon, where by default they start to count at 1. In C we start to count at 0. Python, it's also 0 because of this. To be precise, in Fortran, you can actually decide the value where it starts. So you can decide in Fortran to have a given array to start at 0 if you want. I typically don't do it because, I mean, it's not the convention of the language in a way. But if you have, let's say, physical representations where 0 has a meaning, like a quadrivector, for example, I mean, I don't know how many people know what quadrivector is, but then we have the 0 component, the first, the second, and the third, then it makes sense to start that one at 0, which will not be possible in C, for example. Wow, but yeah. So you can either say undefined size, and then basically that at the definitions here you get the size, so it could be size 5, or you can define from the start 10 elements, and then it has 10 undefined elements. So that depends of the compiler if those 10 elements will by default at 0 or not. So in principle, the behavior is undefined, so the compiler can decide to let whatever value are from the previous code, basically in that space memory, or to reset them to 0. You can force the compiler to do it, but by default, you don't know what he's going to choose. But at least don't assume he's going to put them to 0. Yeah, and then for the rest is basically, let's say, typical. Yeah, that's interesting. So my question is, which of those two codes are valid? So in this case, I have a function which is trying to compute the average of an array. In one case, I pass the pointer of the array. In the second case, I say it's an array. I don't specify the size at all. And in both cases, I actually use the array syntax to access the elements of my array. So which code is going to be valid? Let's look. Whoa, we have expert here. Yes, actually both are completely valid. That's good. Because basically the way the array is just a different syntax for the same object.
I would have chosen the right one.
Yeah, but in practice, it's exactly the same. So you can use both are valid. But the way the array works is basically you pass actually the entry of the first element and the address of the first element. So that's why for the array in practice, since you pass only the entry of the first element, passing this or this is actually the same for the code. And the advantages of that, oops, I'll get out of my presentations. The advantages is that, for example, if you want to compute the average, not from the beginning of the array, but for, let's say, the last fifth element, then you pass the first element you want to start with, and the number of elements you want because of this function, and then it will work in both cases. So that's the advantages in a way, is that you don't have to pass the full array and don't have to recreate a new array with only the elements you want. You pass basically the first element and how many elements you want. Okay. Yeah, one difference between Fortran and C, I mean, the most annoying difference between Fortran and C is how array are stored. So when you have two-dimensional array, then I never know which one is which, but the way they store elements in C is by line, while in Fortran is by columns, or the opposite. I don't never remember which one is which, but that's the big difference. If you need to basically interface a Fortran code with Python or a Fortran code with C, and then you have array, I mean, basically a 2D array, then you will need to transpose a lot of elements. Okay, so I promised you before that we're going to go back to strings. So the way strings are handled in C are basically array of characters. So this is a string, and you can actually define just like this, which is fine. But basically what is important to know a bit is that the way to finish a string is this character /O, and that's saying that my string is finished. So when you do this, if you count the number of elements, you see that you have 1, 2, 3, 4, 5, 6 elements, and not 5 actually. And you have a couple of very basic functions for strings. So copy, concatenate, and what is the length of your string. So compared to, let's say, Python and stuff like that, handling string in C is a pain. So trying to find path or file and stuff like that is quite painful. Python is much more flexible, obviously. So I still have two stuff. 15 minutes, that's fine. I want to say. So one thing you can also do in C is data structures. So instead of passing only integer, float, and stuff like that, you can define a structure which has multiple data inside. So that will say, for example, here I have formations with a title which will be C lectures, a speaker which will be my name, and the number of students, which in this case will be 11. Then I pass to my function directly the structure instead of passing 3 arguments. So that's a better way to basically encapsulate your data because you have all the data together in a way than having to pass 20 different elements, which correspond to the same thing that can be then out of sync, right? Then you pass the full stuff. Then we'll see, I guess, in the next slide, how to use in the functions. So I can pass, of course, a structure to a functions. The only difference I need to have this struct argument. So struct, then the type of structure, which is formations, which was the keyword I used. I'm going in the wrong directions. I use here. That is the name exactly like an integer or an int, because I now have my own name called formations. I can put here, and then here that's the name of the variable. So that like here I can put whatever I want. One thing So you can pass them, of course, by value, or you can pass the pointer, as before. So this allows you to change the content of the structure. In this case, you will not be able to change it outside of the functions. Exactly like before. And one syntax stuff, I'm not sure why it's more practical. If you have an address of a structure, you can take this arrow, so this hyphen and then the bigger, which is with the arrow, you might see it better here. And then put the name of the variables that you want to use inside. So it's directly from the pointer, you can get the argument, which is exactly the same as doing this. You take for the address, the star to have the variables, and then dot, and then you will have the value. Okay, not sure why. I mean, this might be more clear, I don't know. But it's just a different syntax. Okay. Yeah, let's do a small check that you've understood that. So here I have a structure, formations, exactly like the one before. And I have two functions that takes a structure formations as input. One is print stats and one is remove student, which takes a second argument, which is the number of students I need to remove, and then doing this. And the question is the function, I mean, if my data structure outside of the functions is going to be impacted or not. Which in principle that you know at this stage. One more answer. With a better result. But yes, the correct answer is nothing outside the functions. So I pass here the object in a way, not the address of the object. So the first thing it's done is to make a full copy of the object, so that I can do whatever with this object will not impact the rest of the code. If I wanted to change, I would need just to put a star here, replace the dot by an arrow, same here, and then it will be modified. That's really the difference between by variables. I pass with the variables, but not the object. I mean, not the value itself. So I just copy everything in memory. But if you pass the address, you just pass the address, and then you can have a write access there. Okay. Okay, and the last thing I want to discuss a bit is dynamical memory. So for the moment, you've seen array, which is a typical object that you're going to use quite a lot. And you see that when you define the array, you need to define with the size. Sometimes you can say unknown size. For function, it works. But when you start an array, when you initialize a new array, you have to define a size. And you need to know, at least in C at runtime, what the size is. And when the size is done, you cannot change the size. So dynamical memory allows you basically to have objects where you can change the size. So instead of having static memory, it's a dynamical memory. It's a different type of memory, but I'm not going to enter into the details. Basically, the syntax is here. So what do? You first initialize a vector, pointer, sorry, a pointer without any value. And then you say, I want to have an array of 3 elements. So here I just define size equal 3. I mean, that line is not really important. And then I ask the code to give me basically a place in memory of 3 times the size of an integer. And what it returns to me is actually the value of the pointer. So now I have as an output, basically a pointer to a place in memory that corresponds to what I asked for. So at this stage, I ask the size of 3. So if you have only that, it would have been better to put directly bracket 3, right? The advantages of this is that I can also change it at runtime via this line. I say reallocate my memory, and now put a different size. I'll put int here in the chart. Actually. So I can also change now at runtime how much memory I want to have access, actually. That's the main interest. The second reason why I introduce this is when you go to GPU, then you will have two types of memory, the memory of your CPU and the memory of your GPU. And what you will need to do is ask, yeah, this kind of variables, give me access to that amount of memory inside my GPU. So that's why it's, I'm basically mainly using that for GPU actually. But sometimes it's better also, to be more flexible, I would say, on CPU. Instead of basically the bad stuff on CPU saying, give me 2 GB of memory for this static variable, so not using malloc, and you actually only use the 5 elements. And why do you ask that much? Or because I don't know at this stage how many I would need. If you do that, you will waste a lot of memory for nothing. And that means it will prevent you sometimes. I had case in the past that was forked on .c, where basically the code was not able to run just because I was asking so much memory, even if my problem was super simple and was basically asking, needing 1 MB of RAM, so really nothing, but I was asking 2 GB. Yeah, at that time, that was a lot. So it was stupid, my code was not able to run on some computer just because I don't have enough RAM, while actually I was not needing it. So if I was using that, I would not have the problem. Okay. I don't think we have the time for the example. So that was a small game of computing the 50 time of the Fibonacci sequence. I will just show you the answer because it's fun actually. So what do you know the Fibonacci sequence is? You take 2 elements which start by 0 and 1, and the next element is the sum of the 2 previous ones. So in this case, and the tree will be 1, the element field will be 1 plus 1, 2, and so on and so on. So very simple. For doing that, I'm taking 2 elements, and what I'm doing, I'm changing. So inside where I'm storing the first element, I'm taking this one. So I'm changing that value. And then for the second, I'm just taking the sum of the previous one. So anytime in RAM, I only have 2 numbers, basically. And then I only need to do a loop of 50. Okay? So relatively simple, I would say, with this. Now I can compile it. I guess it's, let's see if it's already done or not. Yes, already done. And then you will see the number. So I ask for 50, and the number is minus 811, and so on. So who thinks that's the correct answer? No one. So how is it possible to get a negative number when I only sum? You see here first it works well, right? 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. So it's working super well. And then at some point here, I think it's really at 50. It's okay. No, that's here. That's happened the first time. Where I'm saying this number and this number, I'm getting a negative number. Yeah, basically I have my integer is only 8 bits. And what's going on when I'm doing the sum of 2 relatively large integers, at some point I'm changing the bit, which is actually getting the sign. And therefore, it's basically just a bug in a way. Just I don't have enough space in memory. And then it's interpreted that new number as a negative number. So those are kind of bugs that you will find all the time. If you play a game and you arrive at, you have a score that at some point you get above 2056 and suddenly the number become negative. That's typically this kind of issue as well. That's basically they encode the number on smaller integer than this one. And at some point you get basically too big for it. This kind of bug you will see every time on game and stuff like that. So what is the solutions? Is instead of using integer, I change the type of my integer, which is in this case unsigned, so that I don't have sign at all. And maybe I've done it a bit too secure, long int. Instead of using, I think, 8-bit, I'm going to I guess 32 or maybe 64 bits. So it's super accurate, but otherwise the code is exactly the same. It's just instead of storing n bits for, I'm doubling or quadrupling maybe the number of bits for my integer. And now if I'm running it, you will see that now I have a number which stays positive. I will still have the issue if I'm updating that to, let's say, 1000. At some point, I will get, again, bullshit result. That will always occur, but much later, obviously. So that's, I mean, one typical reason of bugs. Okay. Okay, so this brings me to my conclusions. I would say, like for any language, the best way to learn is to play and asking yourself, oh, can I do that? Can I do that? Try the syntax. I mean, the syntax, they will always have some weird stuff in any language. The same in Python, you have stuff that are completely stupid, I would say. Same in C, in Fortran, will always have stuff that are a bit weird. The best way to learn the language is what's happening if I'm doing that. Make the code to crash at compilations or make infinite loop just to check what's going on. That's always the way to learn. Try to have a good way to write your code. As Damien said last time, you write for yourself. So put a lot of comments, explain what your code is supposed to do, and try to stick to always have the same number of space everywhere and stuff like that. That improve your credibility. One key reason for basically these lectures is that it's super important to understand C if you want to understand also Python, if you want to understand Fortran, if you want to understand any language, basically. If you don't understand my lectures, you will be stuck at any stage. And of course, I mean, there is two parts in my talk today. One is learning the syntax that you can do by yourself in principle, but also learning the abstraction. We are more generic than C in principle.